Hello, class, and welcome to part 2 of Geologic History. In this section, we'll be going over the correlation techniques. As discussed in the previous section, we talked about the law of superposition, original horizontality, cross-cutting, and determine the sequence of events in a rock outcrop. So what we're going to be doing is we're going to be practicing this a bit, with a bunch of different examples. In this example, we're going to look at diagram A, which is on the bottom left. This sequence started with the deposition of sediments to form rock layer D, C, B, and A in this order, because we know that the oldest rocks are on the bottom and the youngest rocks are on top. Because the oldest layers are on the bottom and the youngest layers on top, and then the F, which represents the fault, splits these layers. And the fault will be the youngest. So when we write this out, we'll see the fault being the youngest. And then we'll work our way down from the top because we know A is younger than B and B is younger than C and so on. So we have this order. The oldest would be the deposition of D at the bottom. Then we see C, B, and A, and then the fault would happen afterwards. Now I want you guys to attempt this on your own. Pause the video, and write in what you think it would be. Now, when you did this, our youngest is going to be on the top, our oldest is going to be at the bottom. Now, the only problem here is that we see an igneous intrusion, which is B. And we only have contact metamorphism on one side. So we had to look back at our contact metamorphism with the igneous intrusion to determine which was older or younger, B or A. Because there's no contact metamorphism between A and B, A must be younger. Then we'll see the intrusion of B, deposition of C, and then deposition of D being at the bottom. Again, the reason that B is younger or older than A is because there's no contact metamorphism between them. Here's another one. Press pause to try it on your own. Now in this example, we see contact metamorphism on top. So we know it must be younger than what it's come in contact with. So the youngest thing is going to be the igneous intrusion of B. Then we work our way down. We have the deposition of A, and then deposition of C on the bottom. Press pause and try this one on your own. Now in this example, we're not dealing so much with the fault or with a igneous intrusion. We're dealing with a fold. So the youngest thing that happened was fold because we see all layers are being folded. Now, once we see that, then we can work our way down the list of our depositing layers, with our youngest being E, B, A, C, and then D on the bottom. Here's another one for you to try. Press pause and start on your own. Now on the top here, we see that there's a lot of missing layers between D, C, B, and A. So what happened there was erosion, or another word that we came up for that was unconformity, a missing part of the rock record. After the erosion, there was the igneous intrusion. We see that because there's contact metamorphism with all the layers. And then we're going to start working our way down. We have our tilting. These are not layered flat. Deposition of D, deposition of C, deposition of B, and deposition of A. Now we're spending some time on this. There's not a lot of emphasis on this on your Regents exam, but this is just good practice. And if you like puzzles, this is pretty fun to do. Try this one on your own. Now in this one, we see an igneous intrusion and a fault. Now, what we're going to need to discover is the fault older or younger than the intrusion? Notice how the intrusion is not faulted. So our igneous intrusion is the youngest. It's not faulted, so it happened after the fault. Then we have our fault of XY. Then we'll go down through our layers of deposition of A, B, C, and then D. The cross-section below shows layers of sedimentary rocks, layers A, B, C, and D, with the igneous intrusion letter E. The ages of the sedimentary rock is identified millions of years ago. What is the possible age of the igneous rock? So this is going to be our relativity. okay, is between what range? Okay, now we see that there's no contact metamorphism with A, but there is with B. So it has to be somewhere between 1.7 to 2.4 billion million years old. Now, what does it mean to correlate? Okay, we might have used this in your English class when you're correlating things of different or comparing, right? It means to match. Now, correlation by definition is the matching rocks and geological events in one location with rocks and geology events in the other location. So if we stood on one side of the Grand Canyon, okay, what's underneath us is going to match what we see on the other side. And we see that similar here, okay, where a river is cut through the valley, and on either side there's rock outcrops, okay, with similar rock record. But we walk the outcrop. Okay, we're going to match nearby rock layers that appear to be the same type and thickness. Okay, so what is the same depth or thickness on one side will match the same on the other side. Same with the type of rock that it is. Okay, because it's part of the same rock layer. It just got eroded away, okay, by a river, or it could have been just us building a highway that we might have blasted out a cut so the road would go flat through the hills. Now, an outcrop is the surface of exposed bedrocks. Okay, we see a lot of those on the highway. If you're driving up towards Albany, you'll see a lot of exposed bedrock on the side of the road where they've had a blast to put the roads in. So the Grand Canyon provides excellent visuals to show how layers of rock can be correlated by walking the outcrop. You can see that in the layers match up across the canyon, okay, as I was referring to before. Okay, if we were standing on the left side, okay, and we looked over to the right side, okay, that would be our visual. Okay, we'd be seeing the same rocks that would be below us. Okay, and this is actually a very nice descriptive layering of the Grand Canyon by rock layers. And you can see how they're all flat. Okay, we have a couple of spots where we see some unconformities. And then as soon as we get all the layers up top, okay, the sandstone, shale, limestones, these are all sedimentary rock layers. Okay, they're easy to be eroded. Now, as we get down to the bottom, okay, we see a little bit of a tilt with the docks, the Shinumu, sandstone, the Hakatai shale, and the bass layer. And then below that, we have our Vishnu schist, which is a metamorphic rock, okay, deep underneath the earth, a lot of pressure. And then we have that granite, okay, that's an igneous rock, okay, part of an igneous intrusion that's solidified below deep into the earth. So if we were to do a little practice with this, okay, we're going to correlate the rock layer by drawing an arrow from A to match where it is on B. Okay, so spend some time doing that. Now, when we look at this, we'll see a matching of the shale layers up top. Now, on outcrop B, we see a squiggly line. Okay, remember that represents the unconformity, and that's the missing layer of the sandstone that we see on the left-hand side. The limestones match up nicely, and then on the bottom, we have two layers of shale, which also match up nicely. Now, the sandstone layer is represented in outcrop A, but not in B. What might be the cause for this missing layer? Okay, I said it before when I was going over it. Okay, it would be erosion, okay, which is created by an unconformity in rock outcrop B. So there's a missing rock record in B, but there is in A. So that's why it's important for us to have multiple outcrops for us to correlate and to match. So when we compare properties, okay, we're matching the color, texture, and composition of the rock strata. Okay, we look here, okay, we see very symmetrical as we go from left to right, but if we go from the bottom to the top, we see a lot of differences. Now, this is going to be our last little exercise. Okay, this takes a little bit of time. Okay, when we're looking at the rocks, okay, we see our gray limestone in location X, but if we look at Y, the gray limestone is a little bit lower. So we're going to look at that, and we're going to try to match up as we go across. Okay, we have conglomerates, red sandstone, black shale, okay, and tan limestone. Now, all these lines in blue match up with locations on Y. So we're correlating between X and Y right now. And if I was to do the same thing from Y to Z, okay, you see where the gray limestone is and the brown siltstone. Okay, the conglomerate layer is missing in location Z, the red sandstone, the black shale, and then the tan limestone, which is here. Now remember, our oldest rock's going to be on the bottom, our youngest rock's going to be on the top. Okay, and if we were to match from X to Z, okay, you see a longer correlation of where the rocks are lower than what we see in Y. So which layer is represented by the unconformity in Z? So if we look at Z, we point out the unconformity, and we see that the conglomerate layer is missing. Now, which rock layer is the oldest? Okay, it's going to be the one at the bottom. Now, at the bottom, okay, we see the tar limestone. We see the gray siltstone in X. We see the location Y. We see the tan limestone. And then in Z, we see the green shale. But the tan limestone and green shale are not the lowest when we compare it to X. But at the bottom of X, we have a layer that's not matched. Okay, that's that gray siltstone. Okay, so that's going to be our oldest rock. Now, what's the youngest rock? Okay, we see that brown siltstone in Y is higher than the limestone in X. But the brown siltstone is the top layer at X. But in Y, we see that there's no layer above the brown siltstone. And that's the unconsolidated glacial deposit. Okay, that's the till, the leftover deposits from a glacier deposit. Okay, where the glacier might have pushed forward. Okay, we have a moraine or a drumlin. Okay, this is all unconsolidated glacial deposits. Okay, and that'll be the end of part 2. In our next section, we'll be going over volcanic ash markers and index fossils. Have a great day.